Ta'lim still having problem? Okay, so anyway, mana dia? Okay. Okay, so uh, assuming later on you'll be able to open up your iTalim. Okay, so this is the homework that you will have to do. And by doing this homework, you should be able to you should be able uh, uh, to do what we have been talking about. Okay, when we talk about forecasting using apa nama ni forecasting using multiple regressions. Okay, so there are soalan that they have to do. So there are about 21 things that you have to do in the homework. Okay, so basically the idea is for you to forecast the sales of a company given the data that you have that's given to you. Okay, and what you have to do is uh, you have to run a few models. Okay, and hopefully the models will be able to uh, help you uh, learn these multiple regressions and trying to forecast using multiple regressions. Okay, so the data that you have been given is this data, okay, where you have the data for sales, data for income, unemployment rate, and then you have two dummies for the season. Okay, and I also include in the data that you have over there the time period. Okay, so that you'll be able, if you want to use this variable, then you'll be able to use the variables. Okay, so let's go back to this. Okay, so what you have here is what you have there is a few things. Okay, you have the variable sales, where sales is the real values of sales for a company in a quarter. Okay, and then income is real income of people in the area. UR is unemployment rate of people in the area. Okay, and what you have to do is, as we have said before, when you want to do any regressions, or uh, when you want to do any analysis, the first thing that you have to do is you have to look at the behavior of the data. Okay, so that's why the first things that you have to do when you have the data is for you to plot the data. Okay, so in this case, you have to plot the data for sales, income, and unemployment rate. And what you have to do is you have to explain the behavior of the to explain the behavior of the data. Okay, so if you look at sales, okay, what is the behavior of sales? Okay, so whether the sale is trending upward, the sale is trending downward. Okay, whether there is a cycle in term of the sales. Okay, and you want to relate the data with the okay, if you see the data that you have over here, okay, you may want to relate to the period. Okay, let me just do a simple thing here. And let me just plot the data using Excel. So you can use any software that you want to use, as long as you are able to get the answer. So let me just show an example here with regard to sales. I, Okay, so this is the data for sales. So you have to plot the data and look at the data. Okay, and try to explain the behavior of the data. So if you want to use Excel to plot the graph, then you can use Excel. If you want to use R or you want to use EViews, whatever software that you want to use, okay, as long as you are able to get to the answers. But what I'm going to be showing later on, I'm going to be showing how using R will be able to get the answers. Okay, and like what I said previously in the class, when you draw a graph, one of the things that you have to do is you have to label the graph, right? Okay, because what you want to do is you want to explain to people who read your graph, okay, what the graph is about. Okay, so because you have to label the graph, so you have to label the axis. Okay, so these are the things that you have to do when you try to explain the data. Okay, so maybe this is time. Let's say this is time, and this is sales. Okay, because presentation is very very important, right? So now people know that this is the graph that show you the relationship between sales and what's the sales in different time period. And when you have this graph, then you'll be able to explain the graph, right? So now you see here, let me get bigger, much longer. Okay. Okay, so what you can see from this graph, one is the graph is in a way it is trending upward, right? So you can say that the sales for that company have been going up, but there are time where it is down, where time it is higher. So you have the peak and you have the trough in the you have peak and trough in the graph. So now one of the things that you can do is you can try to look at when is the peak and when is the trough. So if you can see here, uh, here is in June. Another one is similarly it is down in June. Similarly it is down in June. Okay, so when it is up, so you have which months it is high. So that's what you want to do. Okay, try to explain the cycle. Okay, one way for you to be able to make it much easier for you to see is you can try to find what is the growth rate of sales. Okay, and you should be able to see in which period the growth rate is negative. And from there, you'll be able to explain the patterns of the data. Okay, because one of the important thing is for you to be able to explain the patterns of the data. Okay. Okay, so that is and then similarly you have to explain the patterns for income, and you have to explain the pattern for unemployment rate. Okay, so that's the first thing that you have to do. Okay, so you have to plot the data. Okay, and then the second one is what you have to do. You have to regress the model. Okay, we have to use ordinary least square. Okay, and we have been talking about how to run regressions using R. Okay, and you also have the YouTube videos that I've posted on iTaklim on how to do all these regressions. Okay, so first one is you have to regress model one, and the question now is, are the sign of the coefficient B1, B2 make economic sense, and explain why. Okay, so after you run, you'll be able to get the coefficients for B1 and B2. Okay, and then you have to figure out what is the relationship between sales and income. Okay, theoretically, when income increase, what should happen to sales? Okay, so that's where you have to relate with your the economic theories that you have learned. Okay, so to know that, then you have to know whether the good is a normal goods, right? Because certain goods you have a very very small percentage of good. When income decrease, the demand for that good increase, right? Okay, so you have normal good and you have inferior good. So if it's normal good, then income increase, sales will also go up. If it is an inferior goods, when income increase, the quantity demanded is going to go down. Okay, so that's where the explanation is going to come in. Okay, when you say that you expect that there is a positive relationship, so in a way you assume that the good is a normal good. Okay, then what is the relationship between unemployment rate? Okay, UR is unemployment rate. What is the relationship between unemployment rate and sales? Okay, so that's where you have to think about the economics. Okay, number three, test whether the coefficients that you have estimated are statistically different from zero. So basically, what you have to do, if you have to look at the t statistic. Okay, and then number four, what percentage of the variation in sale is explained in model one? So okay, you have to look at the results from your regressions. Okay, which of the indicators tell you the percentage of explanations by the model? So you're going to be using your R square in this case, right? Okay, and then you have to test for serial correlation, homoscedasticity, multicollinearity, and normality of error term for the regressions. Okay, so then have to answer whether the model one is appropriately specified. So if you have if the model have serial correlation problem, if the model is heteroscedastic, if the model have multicollinearity, if the error term is not normally distributed, then the model may not be appropriately specified. Okay. Uh, Okay, and then question number six, use model one to make forecast for 2017 quarter one through quarter four, given the forecasted value for URN and UC. Okay, so now you already have the coefficients uh, uh, for the uh, for the variables. Okay, and you know what is the unemployment rate in 2017, the fourth quarter, and then the income. Then you should be able to use those numbers to forecast what's going to be the sales 2017. Okay, number seven, actual sales. Then you have actual sales for 2017. Now you want to see how good is your models. Okay, so how good is your models? One of the way is you can calculate the map. I'll put the plot data again lah. For whatever reason, I forgot what is map. Uh, mean predicted error or something. Let me tiba-tiba boleh lupa what is that MAP. Okay, mean absolute percentage error. Okay, so what is the mean absolute percentage error? Okay, when you have this. Yeah, I think I've given the I'm not sure. I think I've given the formula on iTaklim how you calculate the mean absolute percentage error. Okay. Then you have to plot the actual data for 2017 with the values predicted for each quarter of the models, and then you have to comment on the plot. Okay, the comment on the plot is going to tell you, okay, how good is your predictions. Okay, so that's the first part. Okay, and then the second part, again, you will have your model two. Okay, so previously, in your homework, what you have done is you have estimate a trend model. Okay, now we have a little bit a trend model that a little bit different from what you have done previously. Okay, where in this trend model, you will also include the two dummy variables that will be able to capture the seasonality. Okay, where the season that we see over here is March and December. Okay, so we want to see whether there is a difference between March and December. Whether March and December is going to give you a different patterns of sales. Okay, and similarly, you have to do the same thing what you have done before. Okay, and some summer and the same thing, and then you have to calculate the mean absolute percentage error. Okay, and in a way, what you're going to be doing later on, you are going to compare the mean absolute percentage error for the three models that you are going to run. Okay, and then the third model is where you have sales, income, unemployment rate, and Q1 and Q4. Okay, and then you are going to be doing the same thing. And the last thing is what you have to do is you have to decide which of the three models are the best models that's going to forecast sales for that company. Okay, so usually this is what you are going to be doing lah. If you are trying to if you want to try to model or you try to forecast something. Okay, because you are going to come up with different models, and then you are going to see which models is the best models. Okay, so after you have decided which model is the best models, then you are going to be using that model for you to do forecasting. So these are the step by step ways to do it. Okay, so in this case, I'm just asking you to run three different models, but in reality, most of the time, what's going to happen is you are going to run more models. Okay, and then you are going to compare which models do you think is the best model, and sometimes you are going to be using different models. Okay, because sometimes the differences between the different models are not very big. Okay, if you see that the differences are big, okay, then you for sure that you are going to use the models that give the least amount of error. Okay, so this is the things that you have to do for your homework. So now let's try to do uh, uh, some exercise on how to do some of the things that you have to do here. Okay, any questions? hopefully everything's okay. Okay, so I have not uploaded this file because when I run the model, I'm not able to do something. Okay, but this basically this what I'm going to show you here is to do some things that is some things that is similar to the homeworks, but we are using different data set. Okay. Okay. Okay, so now let's go line by lines of what we have in this R code. Okay. Okay, of course, if let's say it is more convenient for you to use other software, then you can use other software. Okay, because there are a lot of other software. If let's say you want to use data, you can use data. Okay, so for those who have not seen Stata before, and this is the interface for Stata, which is much, okay, in a way is much easier. Okay, but Stata do not have, may not have the things that you can use with R. Okay, and then you want to use this software, you have to, legally, then you have to pay. Okay, you can also use eView if you want to use eView. Okay, so I think for econometrics, you have been using eView. So this is eViews. Or if let's say you want to use SPSS, then you can use SPSS. Any software, a lot of software are able to do. Okay, what we want to do over here using R. The thing is that the R or R is free compared to the other software. Okay. Okay, so last time I've shown you uh, how to upload the data or how to import data set. Okay, using different command. Now I'm using a different command. Okay, to upload the data set. Okay, but the first things that you have to do is you need to import the data first. Okay, since the data that you have is in Excel, then you can import the data from Excel. So in this case, I am going to be using this data, April 16, 2022. Okay, and this is on my computer. So I have to go to the directory where I have the data. Yang satu version 2. Okay. Okay, so there's a few things for you to do. Last time, what I've done is I've attached this code on R. Okay, now instead of attaching the code, then I'm just using a shortcut. Mana dah? Which file I'm using? Good. Okay. So this is the file. The first line is just attaching basically importing the data. Okay, so now they have run import the data, and I name the data as April 16, 2022, version number 2. Okay, so having uploaded the data onto the computer, now what we can do is we can try to look at the data. Okay, how does the data look like? Okay, there's a few ways to look at the data. How does it look like? Satu ada data. In this one is the data. Okay, so this is how the data look like. Okay, so this is a little bit different from the data that's given for your homework. Okay, where we have more data here. Okay, data for sales, data for income, data for the one that we talked about. I think the one that we talked about on Monday. Okay, the data for consumer sentiment, unemployment rate, and then I think this is interest rate, then the dummy for quarter 2, quarter 3, quarter 4, and we also have over here dummy for recession, okay, and then a time. Okay, so that's one way for you to look at the data that you have. Okay, then you can also run this command str, and then what is the name for the file. And if you click run, row number 3 over there, then down there it show you the first few part of the data. Okay, and whether the data is numerical, what's the data about. So you have a number, or you can use the function head and then file name. Okay, it's going to give you something that is similar. It's just the way it presents are a little bit different. Okay, sales, income, unemployment rate, and all these things. Or you can also summarize your data. Okay, if you look at row number 5, summary, and then file name. So here you have a summary of the data that you have. Okay, so you have okay, so if you go to the variable sales, okay, so if you go to the over here, so this part gives you the summary of the variables that you have. Okay, so you have the mean. Okay, the minimum, not the mean. The min is, even though it's mean, but this is minimum. So what is the minimum value of the data? Okay, so what is the first quartile of the data? What is the median for the data? What is the average or the mean for the data? What is the third quartile? And what is the maximum value of the data? Okay, so if you are writing an academic paper, okay, or you are writing a research report, okay, so if you are writing a research report, so maybe some of you will be working in research departments of whatever. Okay, so if you are working in the research departments of a research institutions, or in a company, or in research department of mutual fund companies. Okay, one of the things that you have to do is when you want to write a report, you have all these variables. You need to show what are you need to summarize the data. So to summarize the data, usually what we are going to have what is the minimum value, what is the mean or the average, and what is the maximum. So that is that three are the most important one. Okay, and sometimes the report will also tell you what is the value, okay, whether the data is skewed or not. So then they are going to tell you the skewness value. Okay, they will also tell you the the kurtosis value. Okay, so if you forget what does skewness mean, what does kurtosis mean. Okay, so basically what this is this summary is going to tell you. The summary is going to tell you whether the data is normally distributed or not. Okay, because the skewness is going to tell you whether the data is skewed to the right. Okay, so you are talking about skewness. And you want to see whether the data is looking like this, or data is skewed like this. Okay, and for kurtosis, it is looking at the height of the curve. Okay, whether it is the middle is very high or the middle is low. But the value for kurtosis, the value for skewness, going to tell you whether the variable is normally distributed or not. Okay, and this is going to be very important if you are talking about the residuals of the regression. Okay, so you have a summary of the data. Okay, so the first things that you have to do in the assignment is for you to run a regression, right? Okay, so you have you have plot the data, okay, and try to explain how the data, what the data look like. Okay, so here there's a lot of different way for you to plot the data. Okay, if you can, I think you can search on the internet how to uh, the function for plotting, different type of plotting, the function on how to put the name for the y-axis and for the x-axis using R. Okay, so you just search plot R, then you are going to get a different type of a lot of different function. Okay, so let me here just plot the so previously I've plot the value for sales. Let me plot another one. Let plot. Okay. Okay. So you see here. So this is the plot for the consumer sentiment, the University of Michigan consumer sentiment, right? Okay, so you should be able to save this graph, and if you want to use this graph for your homework, then you can just paste copy and paste this graph. Okay, so you can also plot sales. Okay, so that's the plot for sales from time period. Okay, you can okay, so you have that thing. I also have another way to plot. Okay, so if you go to line 15, row 15 over there. Okay, so let me run this row 15. Okay, so this is another way to plot the data. Okay, where you have the sales at the y-axis and DPIPC at the x-axis. Okay, and you have the relationship between sales and DPIPC. And if you look at row number 15 over there, okay, we ask R to color red the all these things. Okay, so okay, if you want to make it much more colorful, then think what you can do. You can just Google, or you can go to the R help, right, to find how do you come about and how do you change all these different color. Okay. Okay, so that is plotting and the data, okay, and summarizing the data that you have. Okay, so the second things that you have to do is for you to run the regressions. Okay, so the regressions that you have in your homework is to regress the relationship between sales and, okay, the first one is between sales and sales and interest rate, I guess. Okay. For sale, what you have to do is the first one is you have to run the regression between sales and income. Okay, so let me run a regression between sales and income. Okay, so if you look at row number 8 here, okay, row number 8 is the command to run the regression. Since what I want to do is I want to run sales and income. Okay, so the first thing is you have to name, you have to tell R, okay, and name your regression. Okay, so I start with the name model test. Okay, and model test as the name for my regressions. Okay, and the command for regression is lm. Okay, and the first variables in the parentheses or in the brackets is the dependent variable. So the dependent variable is sales, and then you have this whatever is the sign of this squiggly signs before number 1 on your keyboard. Okay, so on your keyboard, before that number 1, you have this squiggly sign. Okay, and then what is the dependent variable? So we start with only one dependent variables, and let's try the dependent variables as DPIPC, as the income. Okay, then you can run the regressions. Okay, so what you have down here, okay, it tell you that you have run the regressions. Okay, so it tell you that you have run the regressions. Now you want to look at the summary of the results from that regressions. So you have your row number 9, the summary, and then you can click run for summary, and you have your results. Okay, so this is the result for your regressions. You have the coefficients. You have the intercept. Okay, so this is the intercept. The intercept is 0.00000064. And then you have the standard error for the intercept. And then you have your t-value for the t-value for the intercept. Okay, whether the intercept is significant or not. Okay, and this is the probability. And you have 1 star here. Okay, and you have the 1 star, 2 star, 3 star. Okay, 1 star is significant at what level of percentage? Okay, 0.01. 0.01 is 1%. Okay, so we have an intercept that is significant. Okay, the value for the estimated coefficient for the intercept is significant, is statistically significant. Okay, so what does it mean by it is statistically significant? It means that the intercept is different from, the value for the intercept is different from 0, and the estimate for that intercept is 0.0000664. Okay, and then the estimate for the coefficient for disposable personal income per capita is also significant. Why is it significant? Because the t-value is 4.144 and the probability is 0.000012. So the probability that it is similar to 0 is very very small. So because of that, this the coefficient is statistically significant. So this is that's the first model that you have to estimate. Okay, and you have the summary of the models. Okay, so this is how you run the regressions. Okay, so that's the first model test. Then you can run different models. So in line 12 there, what you have is you have another model. I give this name model. I give the name for this model as model 1. And for model 1, I run a regression where we have 1, 2, 3, 4, 5, 6, 7. We have seven explanatory variables. Okay, or seven independent variables, and the dependent variable is still sales. Okay, so that's how you write the command. So the first initially you have to name your model. Okay, so your model here is model number 1. So for model number 1, what you are doing is you run a ordinary least square regression for that model where the dependent variable for the model is sales, and the explanatory or the independent variables for that model 1 is disposable personal income per capita, consumer sentiment, unemployment rate, and then you have the dummy of quarter 1, quarter 3, quarter 4, and then a dummy for recession. So similarly, after you run the regression, you want to know what is the result for that. What is the result for that regression? So this is the result for the regression down there. So this is the result for the regression. Okay, so you have the estimate again. Okay, you have the coefficient for income, coefficient for the different thing. Okay, similarly, what you have to do now is you want to know whether the coefficients that we have are significant or not. Okay, so looking at the results that we have here, the intercept is not significant, so it means that intercept is not different from 0. So you can start with intercept from 0, okay, and then we have the coefficient for the different variables over here, and then you have some variables that are not significant. Right. Okay, so you have some variables that are not significant over there. Okay, and how do you interpret the variables? I think we have talked about the interpretation of the variables. Okay, if the variables are at level, okay, it means that you do not do anything to the variables. You do not change. You do not transform the variables. So it's just that it's just basically dy over dx. Okay, so when you have that variable changed by 1, okay, how much is the change in sales? Okay, so if let's say for income, the coefficient is 3.49. So you mean that if income increased by 1, sales going to increase by 3.49. Okay, and the same thing for the University of Michigan consumer sentiment, and for UR. Okay, and then you have to know how do you interpret the dummy. Okay, the dummy is kind of like the interpretation for intercept. Okay, so it's just showing you in quarter 2. So quarter 2, if you look at quarter 2 is not significant. So because quarter 2 is not significant, then okay, what is the relationship between quarter 2 and sales? Okay, so quarter 2 do not have, in a way, do not have an effect if you compare quarter 2 with quarter 3, or quarter 1. Okay, the only quarter that is significant over there is quarter 3. So you have a positive value for quarter 3. It means that, okay, so when it is quarter 3, the sale is going to be higher than the other quarter. Okay, so and then you have a recession. The recession is negative. It shows that a recession have reduced the sale. Okay, and then if you go down, then you have the value for. Okay, if you go down here, you have the value for residual standard error, and you have the value for multiple R square. You have the value for adjusted R square. You have the value for F statistic. Okay. Okay, so what is adjusted R square? Adjusted R square tell you how much does the model explain the data, right? So the adjusted R square is 0.8581. So it is 85.81%. So it means that it is explaining 85.81% of the data. Okay. Okay, so that is if you run the regressions using 1, 2, 3, 4, 5, 6, 7. Variables. 7 good. 1, 2, 3, 4, 5, 6, 7 variables. Okay. Okay. So like I said before, okay, what you want to do is you want to try to see which model is the best model. Okay. And then you can run another models. Okay. Before running another, because I think you already know how to run the different models. Now, one of the things that you see here is that the estimate for the coefficients that you have over here, you have small numbers, right? 0.000 something. Okay, because it is E03, so everything's are over here in the scientific term. Okay, so sometimes what you want to do is you want to have a much smaller number, okay, much smaller estimates. Okay, one of the things that you can do is you can also transform the data. Okay, you can transform the data. So initially the data that you have is sales. Okay, so initially the data that you have is sales. Let's look at the sales value. Okay, so this is the sales value 152641. Okay, whereas the value for unemployment rate is only 5.7. Okay, small. So you have one number that is big and one number that is small. So one of the reason that you have that big coefficient is because one number is big, one number is small. Okay, so what you can do is you can transform the data, okay, and see what's going to happen if we transform the data. So now let's say we want to transform the data, okay, where initially sales is at level. Now we want to transform the data from sales. We want to take the natural log of sales. Okay, so if you want to take the natural log of sales, okay, then what you have over here is line number 18, row number 18, okay, where you transform sale to become natural log of sale. So that's the first the so initially what you have to do, you have to name the new variables. Okay, so you name the new variable as ln sale, okay, natural log of sale. Okay, and then you have the formula here, the log. Okay, you log the variable sales. So you have a natural log of sales. Okay, so now let's see if, let's say, it have uh, changed the size of the estimate. Okay, so if you go to row 19, okay, we have another model, model 3. Okay, so why is it that we have to name all these models so that we'll be able to save the results? Okay, so later on when you want to look at the result for model 2, then you can just summarize. You can just type summary model 2, then you'll be able to get result for model 2. So if you don't change the name, then the result is going to be deleted. Okay, so let's try to run another model 3 there, where the dependent variable is natural log of sales. Okay, and then look at the summary. Okay, so what you have in this case, you have the numbers become too small. Okay, it becomes 0.0000. Previously is much bigger. Okay. Okay, so now let's say we take the log of income. Okay, and run model 4, log of income. Okay, now you have a much better we have a much better estimate. Okay, where when we run a natural log, okay, now model 4 over here. Model 4 is natural log of sales as the dependent variables and the natural log of income as the explanatory variables. Okay, and what you have over there, the estimate is a number that is much easier to work with. Okay, but what happened when you transform the data? Okay, when you transform the data, then the interpretations of the coefficient also change. Okay, I think in the on iTalim you can download how to interpret this transformation. I think I've put it over there. Okay, when you have a natural log. Okay? So when you have a log model. Okay, so this is the models that you have is log model. Okay, so in line 22 over here, model 4 is a regression of natural log of sales against natural log of income per capita. So what you have is a log model. Okay, both the dependent variable and explanatory variable are in log. Okay, so when you have that log model, you can the interpretation of the estimate is in terms of elasticity. Okay, the natural log, the interpretation of the estimate is in terms of elasticity. So I think you still remember price elasticity of demand, right? So we are talking about price elasticity of demand when price increase by a certain percentage. What is the percentage increase in? What is the percentage increase in quantity demanded? Okay, so that price elasticity of demand. So the same thing over here. This is uh, in model 4 over there. The interpretations of the estimate for coefficient for income is the income elasticity of sales. Okay, how sensitive is sales to changes in income. Okay, so you can the interpretation is in term of elasticity. Okay, instead of income increased by one, how much is the increase in sale? Okay, so when you have log here, natural log model here, okay, you are looking at when income increased by 1%, how much is the percentage increase in sales? Okay, so again, how do you interpret the coefficients? Okay, so what you have over here, 0.4963, income increased by 1%, sales is going to increase by 0.4963%. Okay, so again, when you have this log model, the interpretation is in terms of elasticity. So here, when income increased by 1%, sales going to increase by 0.4963%. Okay, because you have transformed the variables into log. Okay, if the variables are not transformed into log, okay, so if what you have is sales and the PIPC, then income increased by 1, sales going to increase by 0.4963. Okay, so that's the interpretation. Okay, and then we can interpret that because the coefficient is significant. Okay, so what if the coefficient over here is not significant? Okay, so what is this t value instead of 3.220? Okay, so what if the t value, okay, the t values that you have over here, instead of 3.220, let's say that the t value is equal to 0.9. Okay, so if the t value is 0.9, most probably the probability is going to be 0.5. Then the estimate is not, the coefficient is not significant. So if the coefficient is not significant, uh, then income does not affect sales. Okay, so in this case, because the t value is 3.220, the estimate is statistically significant. So we can say that income increased by 1%, sales going to increase by 0.4963%. Okay, so if let's say instead of 3.220, the t value is equal to 0.5. Okay, a small number. So if that is the case, then the interpretation is that there is no relationship between income and sales. Yeah, because the coefficient is not statistically different from zero. So that is if t value is small. Okay, so let's try to let's go to row number 24, model 5. Let's change model 5 a little bit. I'm not sure what's going to happen. Let's change now the dependent variable is log sales, and we also take the natural log of income, and then the other variable we do not transform the other variables. Okay, and see what's going to happen. Okay, so this is what happened. Okay, to the results. Okay, let's say tengok result atas dia. Okay, so this is the initial results where we don't take the log. Okay, so this is for model 1. Right. For model 1, this is what we have, right? This is what we have, where the estimates where where they estimate small numbers. Okay, now after we take the log, natural log for sales and natural log for income, we have a number that is much easier for us to interpret. Okay, rather than having that E, you don't have that E anymore. Okay, because sometimes you want to transform the data. Okay, so that the estimate is something that is much easier for you to interpret, and much easier for you to see the relationship. Okay, so again, after after transforming the dependent variable to natural log and transforming income to natural log, the value for sales and the value for income uh, become smaller. So because of that, the estimated coefficients, you do not have that very small number. Okay, so you have the relationship between income and log of sales. So it's still elasticity. Okay, but the relationship between the other variables and income are not elasticity. Okay, the thing is that after you get this better number, the interpretation is going to become harder. Okay, so you can refer to the interpretations on the notes that's given. How do you interpret the coefficients when the dependent variable is natural log, when the dependent variable is natural log but independent variable are not natural log. Okay, when the dependent variables are at level not natural log but the independent variable are natural log. Okay, because sometimes we want to transform the data. Okay, so after getting all this, some of the things that you have to do in your homework is to test the residuals. Okay, because if you still remember, the assumption when you run OLS is that the error terms are homoscedastic, the error terms are normally distributed, the error term do not have problem of serial correlations, and then the variables are the independence variable do not have problem of multicollinearity. Okay, so how do you test for that? And then you have to look at the behavior of your residuals. Okay. Okay, so we have run model 5. Okay, so now let's look at the residual for model 5. So in line 32 that you see there, the row 32, I've named residual 5 as residual from model 5. Okay, residual is the error. Okay, I've named residual 5 is the error term from model 5. Okay, so now let's look at let's plot the residuals. Okay, so line 33, plotting the residuals. So that's how the residual look like. Okay. So one of the things that we want to have is that we don't want the residual to have any pattern. Okay. Just looking at the graph that you see here. Okay, the graph in southeast part of your of the slide of the computer. Okay, so you have these are the residual. It look kind like there is no pattern for the residual, right? Okay, so it's not like you have a straight line data. Okay, so that is one of the things that we want to happen lah. Okay, with regard to the data. Okay, just plotting the data, you want to see whether they are issue with the error term or not. Okay, but so this is just Okay, so this is just looking at the data, it's just plotting the data, but we also want to see statistically whether they are issue or not. Okay, so there are a lot of different library that will be able to test these residuals. Okay, again, you can Google R function. Okay, in testing residual is going to give you different ways of testing normality, different ways of testing serial correlation, different way of testing uh, whether they have apa tadi homoscedasticity and all those things lah. Okay, so what I'm doing over here, I'm using this library. This library have different function, okay, that will be able to help us test the behavior of the residual. So I call this library OLSRR. Okay, and if you run, then they are going to download the library onto your R. So here, uh, there's not much thing coming out because I've already have that library on my computer. Okay, so if you don't have that library on the computer, what is going to happen over here is that okay, a lot of things going to come up, a lot of script going to come up where they will be downloading the libraries from the R database. Okay, so after downloading the library, then I can run a few of the commands that we have over here to test normality. Okay, the first one that I want to test is I want to look at the plot of the residuals. Okay, so line 35, the OLS plot residual QQ model. So basically, this one is looking at the plot of residual quartiles with a normal quartile. Okay, so what you have in this normal QQ plot is that okay, on the y-axis you have the sample quartiles. Okay, on the x-axis you have a theoretical quartiles. Theoretical quartiles over here is a quartiles what it is showing you the theoretical normal shape residual. Okay, if your sample residuals is similar to a theoretically normal shape residuals, then this blue dot over here will be exactly on this red line. Okay, that blue dot is going to be exactly on the red line. So the idea here is that okay, our assumption is that residual is normally distributed, right? So when residual is normally distributed, okay, when we draw the residuals, when we draw the histogram of the residual, we should get histogram that looks exactly like this. Okay, if the residual is exactly normally distributed. Okay, so then what's going to happen when we'll be able to calculate all this quartile, how many data points are on all these different quartiles. Okay, so this is the theory. Okay, so this is the theoretical distributions. So what we want to do is we want to compare theoretical distribution with the sample distribution. Okay, so what do you mean by sample distribution? This is the distribution from our residual. Order 5 residual. Okay, so this what the computer is going to do. The computer is going to use this model 5 residual to draw this histogram. Okay, if the model 5, the histogram from model 5 residual is exactly similar to the theoretical distribution residuals, then you are going to have all these blue dot if it is exactly the same, all the blue dot is going to be on this red line. Okay, so what we see over here, there are dots that are far away from the red line, okay, especially at the beginning and then at the end. Okay, so this is a small indication showing that the the residual may not be normally distributed. Okay, because you have data that are far away from that red line. So this is one indication saying that the error term may not be normally distributed. Okay, even though the previous plot that we see, okay, so even though this plot show that it kind like there is no pattern in the data. Okay, but when we statistically run, okay, we see that there is the error term may not be normally distributed. So this is one indicator. Okay, so we can also run a battery of tests. Okay, so if you go to row number 37, OLS test normality. So this OLS test normality going to give us a battery of, going to give you 1, 2, 3, 4 result of tests, whether they are normally distributed or not. Okay, so those are the results of the test. Okay, so the nulls are that errors are not normally distributed. So in this case, you have tests saying that they are, okay, you have your Shapiro test, whole number of tests, Kramer test, and Anderson test. The thing is that one of the tests disagree with the other three tests. Okay, so this Kramer test say that it is normally distributed. Okay, because you can reject the null hypothesis that they are not normally distributed. Okay, but the other two tests say that they are not normally distributed. Okay, so usually, okay, you do have this thing happening, okay, sometimes, okay, where when we do testing, some tests say that some tests say A, some tests say B. So in this case, one test say that it is normally distributed, three tests say that they are not normally distributed. So because of that, we can say that they are not normally distributed, because three say no, one say yes. Okay, so that's the idea. Okay, so that's normality test. Okay, then we can also test for we can also test for correlations. Ni mana test? Tak payah layan ni. Okay, okay, we can also draw a histogram of the residuals. Okay, so the histogram of the residuals look kind like normally distributed. If you get rid of the bar at the right, left. Okay, so it is not a clear say that it is normally distributed. So in this case, we can say that for model 5, the error term are not normally distributed. So if the error term are not normally distributed, so then we have to do something with the we either drop some variable or change the transformations, or we add more variables into the data to make the model better. Okay, but sometimes people just don't care. Okay, they just report the data, because there are times where you will not be able to get any more variables. Okay, because to get data is not something that is is cheap. Okay, it is very costly. Okay, not just in money term, but also in term of time. Okay. And you can also test for the Bin-Watson. Okay, so here to test for the Bin-Watson, the Bin-Watson is going to test for serial correlation, right? Okay, so here I call the library car because the function serial correlation is in that library. Okay, and then we get the result from the Bin-Watson test. The Bin-Watson test, the Bin-Watson statistic is 1.216776. Okay, so if you remember your Durbin-Watson statistic, there is no issue of serial correlation or autocorrelation if the DW statistic, the Durbin-Watson statistic is around 2, right? Okay, so if it is much higher than 2 or is much smaller than 2, then you have serial correlation or you have autocorrelation, or here, okay, it is showing you that you have autocorrelation issues, and the p values, okay, tell you that you have an autocorrelation issues. Okay, so those are the things that you have to do, okay, uh, when you run the regressions. Uh, okay. Okay, so one way for you to do your homework is for you to use R. Okay, if let's say you are not comfortable with R, you can also use other software that you are comfortable with. I think I should be able to understand because I've used all the different software. Okay, so if you think that you are more comfortable with reviews, then you can use reviews for you to do the homework. But keep in mind that later on, okay, when we do more thing on big data, okay, where reviews or there are things where data reviews or SPSS are not able to do. Okay, so if you want to try to practice, then you should try to use R at least for this homework, because currently it is still easy. Okay, later on when we are going into more of the big data, then the ready-made software may not be able to help you. Okay, so basically the idea now is you run a regression. Okay, you get the coefficient result from the regression. Okay, and then you want to test whether the error term satisfy all the assumption. So if it satisfy the assumption, then you'll be able to use that model. Okay, so after you are able to use the model, then you want to compare which model are the better model. So that's why in the homework you are asked to estimate 3 models. Okay, so what you have to do now is you need to compare which model is the best. So which model is the best? Then you have the one way for you to determine which model is the best is to use that mean absolute percentage error. Okay, which model have the highest mean, have the lowest mean absolute percentage error? So the model with the lowest mean absolute percentage error is the best model. Okay, uh, the the formula how to calculate the mean absolute percentage error, you can refer to your ITALIM. So basically what's going to happen is you are going to compare the the value, the actual value, and the predicted value. Okay, and get the difference, get the absolute difference, and calculate, okay, how much is the error. Okay, so that's how you do. That's one way for you to use multiple regression for you to do forecasting. So in the homework, the future data for some of the variables are given to you. Okay, so in the homework, the future variable for some of the data are given to you. So the data for income and unemployment rate are given to you. Okay, so but in real world, most of the time you will not have the data. So what can you do if you don't have the data? One way is for you to just use the last period data. Okay, or you can find what is the average values of the past for the past few years for you to estimate what is the future value of the explanatory variables. Okay, so let's stop over here. Okay, hopefully you'll be able to figure out how to do it. Okay, if you have questions on how to do the assignment, then you can post on the Telegram. Okay, hopefully there's not much problem in trying to solve the homework. But again, one of the things that you have to look at is your how you present your work. Okay, when you draw your graph, how you draw your graph. Okay, so you don't want to just put the graph without axis name. Okay, because when we don't have axis name, then people will not be able to understand. Okay, you have to keep in mind when you want to present, you are assuming that the people who are going to be reading your work don't know anything. Okay, so you want to try to explain as much as possible what you are doing, okay, so that people will be able to understand. Okay, so let's stop over here if there is no questions. Okay. Yep. In fact, I'll discuss the past homework later. Okay, maybe next week. Okay. So to discuss whether you are on the right track or not.
Thank you, sir.
Okay. So see you on Monday. Assalamualaikum warahmatullahi